Hello and welcome to TidyX 117. My name is Ellis Hughes.
And my name's Patrick Ward. And we just wrapped up a section on objects and we did a massive kind of tournament simulation. And now we've decided to go back to Tidyverse and talk about some tips and tricks that we find useful when doing like data cleaning and data engineering and things that like we've been asked by colleagues and people or students sometimes when they're doing their data cleaning and data engineering. And so we're going to go through a whole bunch of these episodes. And if you have any things that you're working on that you're like, gosh, I wish I knew a way to do this or solve this, and you're thinking, maybe I'll stick it to Stack Overflow, you can drop it on our YouTube channel and maybe we'll address it right here on this show.
Yeah.
Today, we're starting out, we're going back to talk about Tidyverse, and we're going into something that I tend to work with a lot. Ellis probably works with a bunch, working in his day to day and business and research type of stuff, is subjects and subject IDs and subject observation counters and things like that, so that you can sort of group subjects and clean your data and filter things and stuff
hmm
like that. So let's jump into the code and build a little bit of a sample data set and then get rolling on this.
hmm Yeah, and also usually if I'm working with actual human data, they're participants. If they're animals,
The,
subjects,
This is a
important.
massive thing. Yes, because like long ago when I was doing my PhD, I would often write in paper subjects, and my supervisor would always be like, "No, no, no, participants."
They're
it is,
participants.
yes, it is a massive thing. Yes,
So this is
they are
completely fake
participating.
data. Clearly, we're generating this, but
Yes, yes,
yes, respect the folks that are willing to be part of these work.
totally,
Just wanted
totally.
to put that out there, throw that out into the world.
Yeah.
So we're
Mm-hmm.
going to start here. We have an R markdown. We have our title and output here. We're still using R markdown. We haven't transitioned over to Corto. So we're going to load library tidyverse. That is the only library we're going to need today. Tidyverse, of course, has a lot of different packages used for data manipulation needs and just makes our lives much easier. We're going to use Tibble, which is a object. It's a fancy data frame, so it allows us to do a lot of different things. But here it's consistent across different R versions, which is why I prefer Tibbles over data frames now. Because if you use an older R version, it can convert them into strings into factors. So that's just a thing that I do now, is just use Tibbles. We're going to create two columns in the Tibble. One is going to be a factor variable that is going to have the values Al, Tom, and Carrie. Al's going to be repeated 20 times, Tom's going to be repeated 35 times, and Carrie's going to be repeated 13 times. And then, so this is just going to be a vector of those three names here, Al, Tom, and
Mm-hmm.
Carrie. Then we're going to have a variable column, and this is going to have a bunch of random values pulled from a normal distribution with a mean of 300 and a standard deviation of 50, and we're going to be pulling 300 values from there, and we're going to round it to zero, so they're going to be integers. We thought then it might be a good idea to add what is the observation number for this participant. So we're going to do a group by subject. So this is going to now essentially split the table by the different subjects that we've got. And then we're going to mutate and create the new variable observation, and we're going to use a seek along subject. And so what this is going to do is this is going to give an index for 1 to the length of subject, but it's grouped by. So it's going to restart for every different subject that we've got here. And so for Al, it's going to be 1 through 20 because we have 20 observations. For Tom, 1 through 35, and then Carrie, 1 through 13. And then we're going to ungroup it because letting your grouped data frames kind of float around can get confusing if you don't remember that it's grouped, and it changes the way functions behave. So you always want to be ungrouping when you're done with that. Let's create dat there, and now we can take a quick look at dat. Let me actually zoom in a little bit too to make it a little easier for folks to see. But there we can go, or there we go. We've got Al, or subject for Al, some variable values, and then observations 1 through 10.
Awesome.
And then we can
Now we
just
have
do a
data.
tail on that too to demonstrate that it does indeed restart and carries the last set of data here. We've got the variable and the observations going up to 13.
Cool.
Cool, cool. All right. So what you might want to look at initially is how many records do you have for individual subjects? Because that is sometimes a really good thing if you're working with like laboratory data or something like that, or even just observational data. You want to know how much data do we actually collect for each participant, because that could change how you approach the
Yeah.
looking at your data. And so
Also a good sanity check. Like if you're doing, like say you're looking at scraping NFL data, you should count and see that there's 32 teams and very
just
basic
just like
things to
things
make
that
sure.
you're
Yeah.
expecting. And
Yeah,
so
right, right.
yeah, we can do this. There's a handy dandy count function that you pass in. You say what do you want to count by, and then just sort it to make it alphabetical. So here we have Tom, Al, Carrie.
Actually make it sorted by the N.
Oh, sort by
Top of
N. Right, right,
Yeah,
right,
yeah,
right, right.
yeah. Otherwise it'll default to alphabetical. Yes, it defaults to alphabetical.
Okay.
Mm-hmm.
Or the order in which it sees it.
Yeah.
So anyway, so we have Tom 35 observations, Al 20 observations, Carrie 13, which matches what we expect. So great. So now we have a basic idea of our data here. Let's go forward on to the next step. Patrick, do you want to take this?
Yeah, so one of the things we might want to do is assign each of our participants a unique ID, because obviously using identifiable names isn't good practice. So one of the ways we can do this is there's this cool function which I I don't know if a lot of people know about. I certainly didn't until a couple of years ago when I found it, but this cur group ID function. And basically what it does is it creates a like a basically a index starting at 1 all the way to n number of participants, however many you have, and it just finds them and it says, oh, okay, that's Al, he's a 1, that's Tom, he's a 2, that's Carrie, he's a 3, or whatever order it is, whatever order your data's in. So the way that this works is we take our data, we group it by our participants, and then we do this little mutate here, and we say cur group ID, and it's a function that takes no argument. And so if we run this, what we end up with is basically this awesome little index here. So if we were to actually do like a count by subject and index, I think you count. Oh, yeah. So if we did the count by subject and index, we see that Al is index number 1, 20 observations. Carrie is index number 2, 13 observations. Tom is index number 3, 35 observations. So this checks out with what we intuitively know about our data. And now we have a quick and easy way in 3 lines of assigning n number of subjects unique identifiers. If we scroll down, there's other ways we could do this. The first thing, actually, before we get into a different way of doing this, is if this works even if there's a randomization of the data. So if the deck was shuffled, because obviously the way that Ellis simulated our data, we had Al 20 times and Carrie 13 times and Tom 35 times. So all we're going to do here is we're going to take that original data set and we just do a quick and dirty sample of that data for the total number of rows with replacement equals false, which basically means we're just shuffling the deck. And by shuffling the deck, now nothing is in order. We can still do this exact same process, and the function knows Al should be index number 1, Carrie index number 2, and Tom index number 3. The only time you're going to run into problems is if you have 2 people named Al and you don't have a way of uniquely identifying them. So it might be like you'd have to create like a last name comma first name or something like that in order to identify them differently.
Yeah, the assumption is that subject does uniquely identify them.
Correct. So that's an important assumption to make. And then the other way to do this is, let's say you have a large data set and maybe you're continually appending that data with observations on new participants. So we'll just create basically a table that's going to externally store these IDs. And here we could now assign the index numbers any sort of number that we want. It doesn't have to be 1, 2, or 3. It could be any value that we want it to be. And when we right join this, it's basically going to say the right data frame. We want everything in the right data frame, which is the actual observations. We're going to join that with everything it finds in the left data frame, keeping all of those right observations. So if we had like a new person in the right data set, in the observations data set named Ellis,
Jerry.
and that
Tom and Jerry.
named like Jerry, right? That person is not going to get pulled into our data here because we have no observations for them, right? So this is another way to do it. It's a second step because you have to create a second table. So I find this to be useful if it's like an ongoing project where you're continually collecting data on new participants or groups and you're updating that data. The other version I find to be incredibly useful if you're working with data like in a very applied way, like sort of, going through data, engineering a data set as you go to build for analysis. You already have the data set. You're not adding new data to it. So two different ways
Yeah.
to get the same thing and assign observations.
And the nice thing about this is by creating this table here is that you always know that Al will be 1, Carrie will be 2, Tom will be 3, and then you can just append these new participants in there.
Right.
With these other methods here, this is great if your data are static and you're not changing it. But if there's a potential for new participants to be included in your data, this is assuming that it's alphabetical, and so the IDs can change for the participants, so that can cause some issues for you.
Yeah.
So this is great because it's super quick, easy, and you don't have to think about, okay, what am I going to assign to these people, or whatever observations that you're doing. But here you do have to think about it a little, like think, quote unquote, a little bit about this to generate the table. So it's like pro cons for every process.
And you have
here.
to always remember there's a little bit of housekeeping here where you always have to remember that if you add new participants or groups, you have to go to this table and append, actually add them into it to make sure. So a little bit of housekeeping, but yeah.
Yeah. It's relatively simple. And then this is just some quick code to demonstrate like these are indeed giving us the same results for every single time. The only difference is with the join is index now is the second column before it was the last column. And that just has to do with the joining because we have the subject and ID first here in this table here, and then we're right joining to keep everything in DAT. So you could relocate if you wanted to, but we decided that it functionally didn't matter to us and the rest of the code, so it's okay. And then here we can do just this quick count on subject and index to indeed demonstrate we do have 1-to-1 Al index is 1 and 20. So we all match.
Way to go. Another thing we might want to do is group observations. So right now we have a bunch of subjects. We could see in the little count that Ellis ran there below in the console. We can see we have a bunch of observations per participant. And let's say we want to count the observations in groupings of 5 because maybe we're doing some research project and we want to say like, how much activity has happened in the 5 groupings, the next 5 groupings, et cetera. Maybe there's like a window function or something like that we're looking at windows of time. And this is tricky because we could see that Carrie has a number of observations that's not divisible by 5. So Al and Tom, this isn't going to be a problem for. We can easily group in 5s and it's totally divisible and we'll have 5 nice groups. Carrie, for whatever reason, has 13. Maybe like 2 observations were bad. Maybe she dropped out of the study or who knows, right? So
whole variety of things.
So this is not an uncommon problem. So we're going to try and solve this. And to do this, we're going to use integer division. So what is integer division? Integer division is basically division where you essentially throw away everything to the right of the decimal and only keep the integer. So we're not worried about the decimal points or the remainders or anything like that. So if we did 10 divided by 7, we end up with 1.428571. We end up with all of these, all of this leftover stuff, right? So we're going to discard that. And to do that, we just do integer division. So we take the parentheses, or sorry, we take the percentage signs and we put the division sign in between of that. And then when we run this, it's going to discard everything to the right of that dot and we get 1. And we can do this with any number, etc. So let's see how this will work. And let's use, oh yeah, go ahead, do an interesting example here.
That one
Zero,
not super
it has to be
interesting.
smaller. Yeah. There you go. Yeah.
But yeah, if you did normal division, it gives you a
You're going to get like
number.
some nasty decimal point. So let's try this before we apply it to all observations, and let's try it on Carrie's data, since that is the most complicated data because it's not divisible by 5. So let's pull out Carrie's data really quick, and we just do a pull function there. So we filter to Carrie, and then we do a pull function, which basically takes that column of data and just turns it into a quick vector for us. So now we have this vector of observations that we see in the console. If we seek along this, we can see that we have indeed a counter of 13 observations. So those are the row indexes for Carrie. If we do our integer division by 5, because that's what we're interested in, groupings of 5, we can see that, okay, this is cool. Integer division shows us that we have groupings of 4, right? Because remember, we're getting rid of the decimal. We have groupings of 4, but we want groupings of 5. So what if we were to subtract a 1 from each of the indexes first? So we're going to use our parentheses because of BOD maps. We want to do the bracket first before we do the division.
PEMDAS
Yeah.
is what I was taught.
Oh, okay. Yeah, no. Brackets, orders, division. Yeah.
Oh, interesting. Parentheses,
Brackets,
exponents,
orders,
multiplication, division, addition,
multiplication. Yeah.
subtraction.
Addition, subtraction. Yeah. BOD maths. What did you call it?
PEMDAS.
Oh, okay. Yeah. There you go. See? Different strokes for different folks.
Hey, it's close enough.
So it went by subtracting 1 from each of our observations. Now our integer division, it works really well. We have 5 groupings for the first 2, and then we have 3. The only thing is that we have a group of 0. So let's just add back 1 to this, and you're going to find that, boom, now we have a group of 5 in the first observations, a group of 5 in the second, and a group of 3 in the third. And so let's go ahead and apply this to every subject. We're going to take our dat ID data frame. We're going to group by subject because we want to retain that grouping. And we're going to then add this in. We're going to mutate. We're going to call this group of 5. And we're going to add in what we just, the code from above, what we just created. And now we have our group data set, and we can explore this. We just write this out to a quick little knitter cabal table. So we get the little kind of divisions there of the columns, and we can knit it, and we have a cool little.
We normally would probably hide the echo,
hide it or make it collapsible or something.
Yeah, toggle it. But there you go. So now you can look at your group of 5 here. You go, okay, Al, for the second set of observations here.
Yeah.
281, 261, 3. Okay, so that's how they're doing here. Okay, and then.
So now you might be like, okay, well maybe you're doing a study where it's like, how does the average variable, the mean of the variable, differ between groupings? And so now you can collapse the data down to do group by group of 5, create average and standard deviation, and do analysis on that. So there might be reasons why you're doing this if you're looking at windows of time, and this is kind of a quick and easy way to do it using integer division and in one line of code. Indeed. And this will handle, obviously with Carrie, this will handle times where there's not 5 observations. The counter will still work.
Yep, exactly. And it can grow over time. All this code is composable. So you can just throw in a new data set at the very top here. And for the most part, except for this joining here, everything should still work. So you can add Jerry in, you can add, whoever
Bob.
else. You can add as many people as you want to this, and it
Yeah.
should all still work because the ideas maintain. And so I think this is great too because we wrote our code in a way that we can recycle it and reuse it for future stuff.
Yeah.
But yeah,
So if you have any kind of tidyverse data engineering, data cleaning things that you're working on that you're stumped with, uh, go ahead and comment on the YouTube channel or send us an email or something, and we'll take it up live on the
yeah,
air.
we'll do it. We'll walk through it. We'll try to answer it for you and try to give you a variety. If there are multiple ways to solve it, we'll try to give you a variety of different ways that you can look at and approach it. But yeah, I think with that, we're going to call it. Thank you as always for joining. My name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. Tidyverse or TidyX is on Twitter at tidy_explained. Tidy.explained@gmail.com, where you can email us. You can go on the GitHub page, get all of our code, take out an issue in the repo, but most people don't do that. You usually just go to the YouTube channel, like and subscribe, drop a comment below. And if you have stuff you're working on in Tidyverse that you're stumped with from a data engineering, data cleaning perspective, comment down below. We'll try and help you out. If our work has impacted you positively and you want to support us, we do have a Patreon page, and we're always appreciative of whatever anybody can give.
Yeah. Thank you all so much and keep on exploring your world.